Okay, shall we get started? Yes? 5 p.m. session on infrastructure as a service. You guys are brave. It's exciting. It's a big crowd. I hope you guys can all find the seats that you need to find. No, so my name is Corey Sanders. I'm the Director of Program Management responsible for infrastructure as a service and cloud services, actually, in the Azure team. Before I get started, let me just kind of get a show of hands. How many people have deployed on Azure before? Okay, how many people have deployed IaaS on Azure, VMs? Okay, a lot of people. You guys sure you should be in an intro session? Well, we'll go at the right pace and make sure that we get the right stuff here and make sure it's interesting and exciting for you. The goals of this session, just to walk through sort of what we're trying to do here today, I'm going to give you kind of an overview of the platform, like maybe 10 minutes, to talk a little bit about how sort of all the platform and we position infrastructure as a service in that platform. Then we're going to do a drill into infrastructure as a service, how it works, some of the components, some of the different aspects that we have, a lot of features that have been shipped over the last couple months, and we'll be able to talk through those, and Brian will come up and do that. And then I'll end with some discussion on templates, which we've actually just announced support on infrastructure as a service literally 2 hours ago. My blog went live. So we'll be able to talk a little bit about that, some of the details on how that works. We'll touch a little bit on Visual Studio integration, and then we'll be done. And we'll get you on your way for the rest of your Wednesday. Sound like a good plan? Does that sound basically what people expected? What are you going to do now? I mean, you could leave, I guess. I guess I can't do anything now at this point. So let me charge forward, and we'll take it from there. So the Azure platform overview. And this just to kind of give you a little touch on sort of what we're looking at here. When we really think about the Azure platform, we really think of it with these 3 pictures in mind. It's very interesting pictures. Let me actually add some description here. Obviously, hyperscale, and this is just the ability to grow and grow and grow. And I'll give you some examples of sort of what this means to us and how we think it's going to apply as we look at the types of services and solutions that you deploy. Enterprise grade, I'll explain this as well. This is, the security and the ability to scale up to the solutions that you want. And then hybrid, which is this fun little gecko with an elephant head on it. That was actually the best picture to find, which is sort of the hybrid story. And we'll spend a few minutes on that, both how that fits in, and then we'll talk more about it when we can talk about the template story later. And so that's actually the fun picture there. So just from a hyperscale perspective, you saw this a little bit from Scott this morning. The coverage, the global coverage, really the growth has been really exciting for us, and we have obviously more coming all the time. 2014, we added the blue dots. 2013 were the green dots. And the coming soon was I guess there was 2 dots there. I made it 1 big dot for the ones that we've announced already in India. From a scaling out perspective, we really sort of want to make sure that the platform can handle all forms of scale out. And this really is some of the aspects of hyperscale that we think of. It's not just the fact that we're in 19 going on 21 regions, but it's also that those regions have a ton of capacity. And we know this because those regions host the capacity to run our other services in them. And so the ability to scale out and handle that capacity is very important, and it'll be important for you as your services grow out. Now, scaling is not all the same thing. So to give you some ideas of some of the things about scale out that we think about, this example here on the right, lots of scaling up and down, being able to handle massive growth in a very short period of time, and then being able to scale back when it's not needed. Some examples of this, the Azure Batch service that we have in HD Insight, which is our Hadoop service, handle this type of frequent and fast scaling. One of the things that I'll talk about when I spend time on templates later, one of the capabilities that we've added with templates is fast parallel deployment. So for those who have used the platform, maybe you're using PowerShell, or maybe you've written directly to the REST API or the Azure CLI, you may in the past have hit some locking errors. Right? You've tried to deploy one and then another VM really quickly after it, and we said, hold on, we're not done thinking about the first one. So a lot of that's going to get better and change with this type of scenario in mind. And so HD Insight actually is one of our most friendly partners deploying on the platform in that they really push us hard to deploy lots and lots of VMs really quickly. Mark's demo this morning, if you were in Mark's session, he didn't actually hit the deploy button on the Mesosphere cluster, but we've been able to deploy in the preview of this new API upwards of about 500 to 600 VMs in about 4 or 5 minutes when they're running Linux. Windows, it takes a little longer for them to start. And so this is really a big goal of ours. It's both having the capacity to handle this and then having the API to be able to handle the calls and requests that you have. And this is a lot of the passion and goal around this new API. On top of this, other types of scaling solutions, things like SQL Database, which actually runs on top of Service Fabric, which was announced this morning. And of course, that runs on top of the same sort of virtual machine infrastructure that we're talking about. It's a very different scaling pattern, right? This is much more focused on 3, maybe 4 instances. It ends up doing replication across them. Typically, it's mostly growing and rarely shrinking. As the data goes up, you typically don't go back down. But the key and critical point for this type of scale is to make sure you're maintaining quorum. Right, and this is actually feedback we hear from the SQL team and feedback we've heard from the DataStax team, the guys running Cassandra, making sure that they can maintain quorum is a critical part of scale out. And so one of the things that we have today, this concept of an availability set, you can make sure that you keep this high availability. Brian will talk about it. One of the big changes with the new API that we're announcing, we actually have up to 3 fault domains now, not just 2. So it allows you to build these type of quorum systems in a much cleaner and higher available way. And then sort of the last one, which is actually Service Fabric as a good example, which is more of a ring structure. And this ends up scaling based on the replicated nature of that solution. Cassandra looks very similar to this, where it ends up building these rings and has to scale out. And this is where sort of making sure communication between your instances is going to be fast. And so for all of these, we feel really excited about having the IaaS platform, being able to host them, to enable these types of solutions that can sit right on top and scale as needed with the capacity to grow based on customer demand. So enterprise grade. When we think about enterprise grade, I'll try and be quick on this one. There's sort of 2 big aspects. One is security, and the other is scale up, not to be confused with what I just walked through with scale out, and the ability to deploy whatever types of solutions or applications you may want. So for security, our primary mechanism for security, this is the data center that we actually have. Our primary mechanism for security is we have one person that pretty much just sits there and watches. No, that's not what we do. See, if there were more people, it would have been like a roaring laughter. It's like, there it is. Whoever that was, front row, here we go. Okay. So let me walk you through a little bit of the approach that we have to security. I want to make sure that I touch upon it. We won't talk too much about it throughout, but I think it's really critical to sort of lay the groundwork for security. So the primary aspect of security, we think of this in sort of 4 concentric rings in Azure all up. Right? This isn't just IaaS, but we end up having to think about it a lot since we're sort of the lowest layer. The first is physical. This is, we lock down the data centers. We lock down, make sure that access has to have 2-factor auth. We make sure that we have cameras and barriers and so on. And this is really an important part, just an assumed part of the security story that we have. When you go in from there, the next one is really on our ability to secure the software. And this is sort of years and years of training and learning in Microsoft to be able to secure software in general. And so understanding how to do forensics when things are happening that don't look normal. How to do penetration testing on our own software. One of the things to think about when you look at sort of cloud and security models of cloud, the amount of data we have coming in is gigantic compared to really any individual provider of infrastructure. And so we can see global trends on attacks and viruses and so on much quicker. And we use that to be able to protect the system and protect your applications as they deploy. The next 2 then really is security we offer you. And Brian's going to go into detail across a few of these areas, but just to give you kind of a sense of the things we offer. One is the ability to have isolated and secure virtual networks. And again, with the new API, to be able to completely manage them in a template-based format, but then also manage them in an imperative way using PowerShell and the scripting language that we offer. And so we'll talk a little bit later about that. Being able to control down access across those virtual networks using ACLing or security groups, which are also a part of the new API. So you can control the security groups, and you can make sure that only specific ports can be accessed between each other, and you can lock down different areas to really make sure your tiers are under control. Azure Active Directory as the primary identity story, so you can log in and make sure that your access to the virtual machines is restricted only to those who should get it using role-based access control. And then the last two sort of go together, security appliances. We have a few of these already in place. We have a lot more coming down the road. Things like Barracuda to be able to lock down your network and make sure that you're securing it using a virtual appliance that deploys in a VM. And we see a lot of excitement and interest in that as we see more and more enterprises deploying into Azure with sort of a connection back home. And then the last of these four concentric rings is the virtual machine. And we have a few areas here that we really like to secure. One is we offer anti-malware. And so we offer free anti-malware on Windows that you can just click and deploy, and we'll put that on your box without asking you any questions. We also offer anti-malware from partners that you can deploy both on Windows and on Linux. And it enables enables it very easy to configure and deploy. And actually, Brian will talk about that when he talks about extensions. Like I mentioned already, role-based access control integrated with Azure Active Directory and being able to use that to lock down who can access what, with the logging and auditing to match that, to make sure you can see who tried to log in and make sure that you're watching that. And then the last key point here is, the key point, it's a great pun, is Key Vault. And this is a service that's in preview right now. And what this is both software and hardware-backed keys and secrets that you can put into our vault that allow you to use it for things like encryption. You can use it for things like passwords, like SSH keys. It offers a lot of control there. For passwords, it ends up just storing it. But for keys, you can actually put asymmetric keys for those who are super passionate about keys and security. You can put asymmetric keys and actually run all your encryption through the system. They never leave the box, right? So they're tied to that HSM. They can't get off, and it ends up being a very secure solution. And so that's deeply integrated with VMs. You can do SQL Server databases on there and encrypt it, and we'll have more and more integration with Key Vault over time. Okay, and the scale-up options. Really the way we look at this is we look at sort of the spectrum of high value and largest scale up. And you sort of saw my two slides, one that gave examples of using IaaS for scale out scenarios like HD Insight. And then there are solutions that require it for scale-up scenarios. A great one is, a big SQL database that you may want to deploy, or even a large MySQL box that you want to deploy. You can use the scale-up sizes, the G series, with 448 gig of memory on the box, and you can use that with premium storage, and you can get the fastest speeds possible with the largest VM sizes to run those really mondo workloads. And so the overall idea is, how do we make sure we can run any workload in any way? And as you look at some of the enterprise-grade lift and shift type scenarios, or at least partial lift and shift, or using components from the on-prem environment into the cloud, these start becoming really exciting options for you. Okay, and then the last one, which of the three to talk about, is the connectivity side. And we sort of really focus on connectivity in three ways. Like I said, we have the virtual network support, where you can lock down and actually select the IP addresses that each one of your virtual machines will get in the cloud. But then you need to figure out how to connect. And the three options we have, one is called point-to-site, which uses an SSL-based connectivity. And what this enables is you can actually connect just from your local box using a VPN environment and be able to treat the entire cloud as just an extension of a VPN of your local box. And I have a slide actually describing that. The other two are a little bit more involved. The next one is a VPN called site-to-site. And that requires a full VPN physical device to be hooked up, or it could be running as actually a virtual device using Windows Server. But that requires a VPN dedicated machine, and that exposes both sites fully. So your entire enterprise site connects to your entire site in Azure. This typically requires more involvement from the IT pro staff, right? They have to get involved and sort of hook this up and make sure the connectivity is going to work and so on. It takes a little bit more time to get going than the point-to-site. And then the last one is Express Route. And I'm not really going to spend a lot of time on this, but this is the ability to work with these telco providers and get this sort of hard line into Azure. It's typically MPLS-based connectivity, folks like AT&T, Verizon, etc. You can also hook up your stuff into a carrier hotel, go to like Equinix and put in your own box in there and use that as your connectivity mechanism as well. And so these obviously have a lot more throughput, have dedicated lines, etc. And so across these three, right, you have the very simple, very fast, very dev-focused option of the SSL point-to-site, and then much more sort of full enterprise, full connectivity option, dedicated line at the bottom with ExpressRoute. And so just to kind of give you a little bit more details on point-to-site, if you had a set of virtual machines running in Azure, front end and back end, they may be on different subnets, right? You may have just assigned them all just relatively random IP addresses, but they are running in a virtual network, and you want to connect to them and do work on them, right? But you don't actually want to open them up to the public internet. Maybe they're just facing internal sites or internal solutions. So what you can actually do with a VPN connection, you can treat them all like an extension on your box. And what this does is it sets up a VPN connection so that it can work with a gateway that sits on our side and actually reroutes the traffic on your local box to reroute it through that VPN and into Azure. And so it does actually restrict it just to your local box, so your entire enterprise doesn't connect to it. It also just goes through 443, which means that typically no additional ports need to be opened, no one needs to be called. You typically can make that connection and actually not have any other person involved. Very much a dev-friendly, dev-focused option for you to deploy with. And so there's a few steps. You have to install a cert and make sure the cert's, it's a secure connection and so on. But it's a very powerful option for really fast connectivity into Azure. Okay. And just to kind of extend, and I'll talk again when I talk about the template story later, the consistency story is a major portion of our overall strategy when it comes to hybrid and the ability to have a single place to deploy all of your apps, a single platform to deploy all your apps. The template language that we'll go into detail later, this is the same template language that you will see coming through for our private and hosted cloud stories, which is our Azure Pack. And this is the ability to take effectively the Azure platform and launch it onto a set of machines running on-prem or in a hosted environment. And so the benefit and power of this is actually really exciting. With this new template language, you can model a fairly involved application, which I'll show you. And that fairly involved application will then be able to launch private cloud, hosted cloud, public cloud, and the exact same end result will come out of it. Right? The same solution that works and doesn't typically need to be fully tested again. And so it's a really powerful sort of multi-cloud option that we're hoping to enable. And as part of this Azure Pack story, we actually do have a large set of partners. And so the purple dots that are now growing onto the map show some of the Cloud OS partners that we have. And these are the folks that are running the Azure Pack today in production. And so we'll see that continue to grow over time. You can see sort of places where maybe we don't have an Azure environment available, or places that maybe there's additional security requirements or compliance requirements. These are hosted in private clouds that are starting to see the benefit of that Azure Pack. And again, over time, we'll see more and more of this grow. We actually already have more than 100 countries, 600 local data centers, 100 world-class partners, and 3.7 million customers deployed on it every day. So it's a very exciting aspect to our overall story, and the template language really should tie it together. Okay, and so that's kind of the overview section. I'm going to turn it over to Brian Sarasi now, who's going to give you some of the foundational infrastructure as a service content, explain to you how this system works, what it does in the back end when you ask it to do things, and then I'll take back over for what's new. So come on up, Brian.
Great, thanks.
Very good, thank you.
Thanks, Corey. Do you have clicker? Where'd clicker go? There it is. No, not it. So my name, as mentioned, is Brian Sarasi. I'm a principal program manager on Corey's team, so the Azure Compute engineering team. So over the next few minutes, what I want to do is talk about some of the building blocks that make up infrastructure as a service in Azure. We'll take a look at the things like the storage components, the compute components, as well as networking. I'll also spend a little bit of time in some demos, just kind of highlighting what it is that we're talking about. And as Corey mentioned, I'll hand that back over to Corey at the end, who's going to give you some insight in some of the new announcements that we've recently made, some of the new technologies, and where we're kind of taking Azure in the future. So with that, let's go ahead and delve in, and let's start with storage. So I saw most of the hands went up and said that you've created virtual machines in Azure. If that is the case, that you know that typically when you create a virtual machine, you will be assigned 2 disks. by default in that virtual machine. If you're running a Windows operating system in the VM, it will obviously show up as a C drive and a D drive. The C drive is your system drive. This is typically where you're going to drop the Windows installation, any other application installation that you have inside of the virtual machine. The C drive does have the potential for disk cache, so for both read and write cache. This is based on the Azure Blob underlying storage system. In addition, we give you a D drive. Now, the D drive is a temporary disk. Don't ever get confused by that. It is a non-persistent disk. It comes with no SLAs. It's not using the same kind of persistent storage that the system drive is. So this is a great drive to put temporary log files, anything that doesn't need to persist, anything that doesn't need to continue along with the VM during its life. Additionally, you can add a number of disks as data disks. So this would obviously show up as E drive or F drive. Based on the size of virtual machine you select, we now have the ability to go up to 64 additional disks attached to a single virtual machine. This thing is running away from me. I'm not even clicking and it's moving. It's saying, move on, move on. So you can attach up to 64 additional data disks to a running virtual machine, and just like the primary system drive, it is based on the Azure Blobs storage. This is the standard blob storage underneath. Now, one thing that we get by default here, and this is really a data assurance statement, is every time you do a write to either the system drive or one of these data drives, we're actually doing it in triplicate. So this is ensuring that no single drive a single drive loss would take down any data. So every time that we do a write, before it comes back and says the write is finished, we've actually done it in triplicate on 3 separate drives on the system. That's again to assure that no single drive failure will take down your data. This gives you the high durability that we need. This is the SLA that we're kind of promising with the underlying storage as well. And as I mentioned, we allow for up to 64 terabytes. So these are 64 single 1 terabyte drives that can be attached. You can obviously use a storage pool to connect all of these together. What we're talking about right here, we're going to talk about some of the advanced storage options in a minute. But here we're talking about the spindle drives. So we're seeing about 500 IOPS per drive. So if you were to take all 64 of these drives, put them in a striped set, you'd be seeing approximately 32,000 IOPS across that disk pool. Okay, so we talked about the fact that we're writing everything in triplicate across 3 different drives. That protects against a single drive failure. In addition, we have ways to protect against a regional disaster or one data center going down. This is called Geo Replication. So we have the ability to copy your disks and your data in your virtual machines to another local, or I should say regional location data center. And it's kind of a balancing act here. We're trying to do 2 things. The first thing we're trying to do is put it far enough away that a natural disaster type of event wouldn't take down both of the data centers. So typically they're over 400 miles away. But the second thing that we're trying to do is ensure that geopolitical boundaries are still maintained. So when you're deploying your virtual machines, you're considering where in the globe they're being deployed. You might be under constraints regarding geopolitical boundaries. You might have compliance boundaries. Maybe you're in a particular industry or vertical that requires you to have your data in one location. So when we're doing GeoReplica, we're not actually taking something that's in Europe and copying it over to the United States. Instead, we're trying to keep it within those geopolitical boundaries. And that's what you see on the map here. So the common color-coded dots indicate the regional data centers that we're doing geo-replication across. So you can see there, for example, in Europe, we have the 2 brown dots. Again, we're not doing a copy across these boundaries. Okay. So in addition to the Azure Blob storage, we also have Azure Files. Azure Files is currently in preview. Azure Files is basically another way that you can attach storage, and the key there is you can enable SMB. So we're actually using SMB 2.1, so if you wanted a shared file location where multiple virtual machines are accessing the same file share at the same time, this is the way that you want to do it. I'll actually show it briefly in a demo in a little bit. Again, it's currently in preview. If you're interested in that feature, you can go to the preview site, sign up for it, and then it'll give you ability through the portal to go ahead and install Azure files. So anything that you want to share, if you have shared settings, if you have diagnostic information that you want to share across multiple virtual machines, if you have application installation packages that you want access on multiple virtual machines, this is a great tool to use for those purposes. And then as Corey mentioned, we've recently announced premium storage. With premium storage, you can attach up to 32 terabytes of storage per virtual machine. We're seeing over 64,000 IOPS per VM, and a single disk is seeing about 50,000 IOPS. We also, and I'll show you in the UI where you can enable and disable this, but if you enable the cache, well, without the cache, you're seeing about a 5 millisecond read-write time. And then with the cache, if turned on, we're less than 1 millisecond latency for read operations against the virtual machine. It's great for data warehousing solutions. If you're building applications and workloads that really require fast and scalable storage, the premium storage is the way to go. And so just visually depiction, again, same kind of thing. We now have 3 different locations. You can go down to Azure Blobs, you can go to Azure Files, and you can also go down to premium storage. And this again applies to your system disk as well as any additional data disk that you want to attach to the virtual machine. Okay. And then one thing I want to talk about, and I'll show you where it is in the UI as well, we have the concept of virtual machine images. So the key here is basically taking a snapshot of the virtual machine and all of the attached drives. So let's say I have a VM that has 32 attached drives. I want to go ahead and replicate that image and maybe deploy over and over again. This is a one-click button. You can obviously also do it through PowerShell to basically take a snapshot of that virtual machine. It works regardless if you're using sysprep or not. So a lot of people will create a virtual machine, they'll sysprep it, they'll sanitize it, they'll essentially get it ready to be used as their gold image. They'll go ahead and do virtual machine image, snapshot against that, and then they can go ahead and deploy over and over again. Additionally, if you have all the configuration and you're not sysprepped, you can do the same thing. Now, as we all know, you wouldn't necessarily want to deploy it back out on the same network infrastructure. You'll run into IP conflicts, you run into GUID issues, licensing server will pop up and say there's duplicate virtual machines. But if you wanted to offload the virtual machine, maybe you want to debug something, maybe if you want to use it in your dev and test environment, this is a really easy method of grabbing the entire VM, including all of the attached disks. All right, so let's move over and talk a little bit about compute. So Corey mentioned some of the new sizes that have come to market. I'll touch on just briefly here a little more in depth. We have the A series. We have a number of A series size VMs out there today. The D series is a newer class of servers. They're based on newer processors. So the CPU is about 60% faster than we see in the existing A series VMs. We go up to 112 gigabytes of memory. So other than the A9 series, our largest VM does what? I think it's 56 gigs in the largest non-A9 series VM. Here with the D series, we can go up to 112 gigs per VM. We also use local SSD storage. Now that's not for persistent storage, that's actually for caching. But again, that's giving you much faster read and access and lower latency times. And the D series is available in all regions and available today. And then the G series, and we affectionately refer to this as the Godzilla series because these virtual machines are absolutely mammoth. They're really optimized for data workloads, up to 32 CPU cores. The largest virtual machine is up to 448 gigabytes of RAM, 6.5 terabytes of local SSD storage. It is using the latest Intel processors in these virtual machines. And again, similarly, you can attach up to 64 disks to that single VM. How many people are thinking they're going to use a G-series virtual machine? They're fun. They're fun. All I can say is I like the fact that I don't have to pay for my Azure consumption because, boy, those things can really start adding up. So anyway, so maybe I shouldn't have said that, but I did anyway. It's out there. It's out there. Okay, so let's talk a little bit more. Let's keep going. Availability sets. So we talked about some of the data redundancy and protection we do on the disk level, with the triplicate copy. We talked about the fact that we do Geo Replication to make sure that, if an entire data center goes down, you have your data and images in another location. Availability set is another way, and this is really how we guarantee our SLA. So if you're looking for the 3 nines and 99.95% uptime, really you're going to want to deploy your virtual machines in what we refer to as an availability set. This protects against both hardware and software failure on the infrastructure itself. It's supported for both Windows and Linux environments. So essentially what we're doing here with availability sets, this is a typical rack, and obviously we have multiple physical machines. I feel like the stage is we're gonna have a natural disaster right here on the stage. I don't know if you can hear, but every time I take a step, I hear cracking. So those are the physical machines in the rack. And then obviously we also have the rack switch, the top of rack switch, and we also have the power unit. And what we're obviously concerned about is what if two of your virtual machines are on, or what if your virtual machine, or two of your virtual machines are working in a pair or a set or a load balance set or on the same physical rack, what happens? So what we do with availability sets is we make sure that that doesn't happen. You create an availability set, you add your virtual machine to that set, and what Azure automatically does is ensure that those virtual machines are deployed on two physically different racks within the same data center. So if the rack goes down, if the power supply goes down, if the network switch goes down, you can make sure that the other virtual machine that's running that workload is not in the same location. So again, for high availability, to get those 99.95% uptime SLA guarantees, you're going to want to create availability sets, and you're going to want to deploy your virtual machines into those sets. All right, so let's talk a little bit about networking. So load balancing, and this oftentimes goes hand in hand with availability sets as well. In Azure, we have the ability to essentially set up a very easy and quick load balancing set and do load balancing. In this example here, we're load balancing web traffic across port 80. This works for both internal and external environments. So if you have customers coming in, again, say wanting to hit a web server hosted inside a virtual machine, or if you have internal clients that are coming through your corporate network, that would work as well. We support both TCP and UDP traffic. We also support ACLs across the traffic. And also recent addition is client affinity. So if you do want the clients to continually get access to the same load balance node, you can set up client affinity based on IP addresses as well. So you can be assured that that same client, assuming that that load balance node is available, that client will continue to get access to that single node. So this is just a graphical depiction of the same thing here, regardless if we're coming internal traffic or external traffic. Here you can see it's a little hard to read, but we have the load balanced system or service running there in front of the web front end or whatever front end it is that you're running, and so we'll equally balance across the web servers. Additionally, of course, you can use a load balanced service in the middle tier as well. So, if it goes off to a back-end SQL database or something of the like, you can also put a load balance service in that location as well. So as I mentioned, load balancing kind of goes hand in hand with availability sets. So in this case, the user comes down to the load balancer. The load balancer is distributing the workloads equally across all the load balance nodes. And you've set those load balance nodes into an availability set to ensure that they're on different racks within the data center. So this is assuring that you're not only scaling out the workloads that are coming in or the requests that are coming in, but you're also protecting against single points of failure within the data center. Okay, so actually I want to switch over now and show some of these things in action that we've been talking about. So I think DisplayPort. Maybe I'm not DisplayPort. Mini DisplayPort. So close. Okay, so let's go ahead and bring up the portal. So here's a portal. I logged in as myself. You can see we have a number of things going on here. If I go ahead and browse, you can see all the different services that I can deploy. I can go into deeper here and see my virtual machine images. So I have multiple virtual machines currently running in my Azure service. Or sorry, virtual machines, not images. We'll get to images in just a second. There's my various virtual machines. And one thing I want to do is just show how easy it is to add a disk to a virtual machine and what that persists inside the VM itself. So I've effectively named one of my virtual machines here lots o disks. So if I click on lots o disks, you can see some of the monitoring information's popping up here. You can see that this is based on a D4 size virtual machine. And if I continue to move over into the settings and move over into the disks, you can see I have, 4, 8, it's something in the range of 12 data disks currently attached to the virtual machine. Again, based on the size of VM that you start with, you can go up to 64 attached disks. And what I want to do is I'm going to go ahead and attach disk. And earlier I was talking about the caching. Here's an option in the UI right here. If I want to do read-only caching on this disk, read-write caching on this. For simplicity's sake, I'm not going to do any host caching. And I'm going to go ahead, and so we can see when it pops up, I'm going to create this. I'm going to just say new disk 1. And we're going to go ahead and say OK. So over in notifications, you can see that it's working on creating a new disk. While that's working away, what I'm going to do is go into the virtual machine itself. So this is the Lotso disk virtual machine. It's running Windows Server 2012 R2. And if we take a look, here's the disk that we talked about earlier. Here's my C drive, which is my system disk. Here's the D drive, which is my temporary storage. Definitely don't put long-term data in there. And what I've also created here is an S disk. So I use storage pool or storage spaces in Windows Server 2012. So if I bring it up, I don't know if you have a lot of familiarity here, but what I'm trying to show is how easy it is to create a very large storage pool inside of a virtual machine and actively add disks and increase that storage pool on the fly. So if we take a look here, if you're familiar with how storage pooling works and how storage spaces works, is I've created a virtual disk which is up to 32 terabytes in size. Currently, these are all the disks that we saw in the Azure UI that I've added into the storage pool. So I think it's, again, it looks like it's 11 disks. And I know that because up here, it's saying that I currently have capacity for 11 disks. And if I come back, you can see that our new disk has been added. And I think, maybe I wasn't looking, but it did look like it just had popped up. So here's an additional disk that came up. I love the terminology here. They call it primordial. So, I mean, this is like pre-existence of a disk. It's doing nothing for us right now. And if I come back down to the storage pool, I can go in, and I can do tasks, and I can add the physical disk. And I'll go ahead and pick that 1 terabyte disk that we just created in the Azure UI and go like that. And it doesn't take long. If you pay attention up here where my cursor is in just a minute, you'll see that our storage space inside of the running virtual machine has gone from 11 terabytes, and now it's at 12 terabytes. So again, we can go up to 64. The beautiful thing about storage spaces and storage pooling in Windows is the fact that you can add it to an existing volume. This is just simply a stripe volume, and you can add it and continue to grow your size inside of the virtual machine. Okay, so just in the UI, let me show you a few of the other things that we can talk about as well. So we'll come back over here, and we'll take a look at some of our virtual machines. Let's go over to Browse. Or we'll go to Home. Okay, so I have a number of virtual machines running. For example, I'll just grab one of my load balance sets. And we'll work our way through the settings as well. If I go over to All Settings, and if I take a look, here's where we set up availability sets. Sometimes there it goes. So you can see I've created an availability set called AV set number 1. It's currently in there. As a little warning is telling us is that you need 2 or more virtual machines in this set to ensure the 99.95% uptime requirement. And you can also choose to pull it out of the availability set. Down here is where you choose the load balance sets as well. So you can go ahead, and it's going to say I'm going to do the changes. You can do a load balance set here, and you can see I've started to create a load balance set number 1. So in the UI, it's very easy to add availability set, add a load balance set and add your virtual machines to that set as well. And then one other thing I want to show here, briefly, I have two other virtual machines. We talked about an SMB share. If I go, actually I'll go back into Azure Portal. We'll go ahead and take a look at my services. And if I take a look at my storage accounts, oops, I hit SQL. Go back, please. Storage accounts. We've created several SMB storage accounts that are actually shared against these virtual machines again. So I have two virtual machines that are actually set up to use the same file share. So we have number 1 right here and number 2 over here. And very simple, very straightforward. Where did my number 1 go? There she is. So here, these are both running Windows Server. Again, they're connected to an Azure file service, which is allowing for SMB file share. So if I go ahead and bring up the file share itself, you can see I'll go ahead and create a new file. We'll just make a text document, say hello world, and right over there on the second virtual machine that's connected to the same file share, as to be expected, it shows up. So again, this is a great way you can have multiple virtual machines connected to the same SMB 2.1 file share inside of the Azure VMs. Okay, so let's go ahead and switch back. Did it pop up? It did. Good. So VM extensions. How many people are actually familiar with VM extensions in Azure? Okay, only a few hands. So most people are very familiar with the concept of a virtual machine image where you have a container where you drop down an operating system, you install your applications, you do all your configuration. Again, a lot of people will actually create this as a gold image then that they can deploy over and over again. What an extension is basically a new method to do real-time configuration of an application or a package or a script inside of the virtual machine. And it can be done at the time of deployment of the VM. It can also be done post-VM deployment. So it gives you a lot of power. It gives you easier management. It supports a large partner ecosystem. So when you're thinking about your applications and you're thinking about development and you're thinking about how to get them deployed into Azure virtual machines, this is an option that should be considered. So one of the key things here is when you think about creating a gold image virtual machine, usually it's a workload or something. It's saying, I'm building a message and collaboration solution. I want to package it as a virtual machine, and that's the way I want to ship it. But an extension oftentimes can be something like an antivirus agent, where you're not necessarily going to create a gold image around an AV agent. You just want an antivirus and anti-malware agent inside of all your virtual machines. So by using extensions, and I'll show it in a minute, we've had a lot of third-party partners build great extensions, such as antivirus agents, such as encryption options, such as client access to things like Puppet and Chef for DevOps orchestration. All of these things are easy to inject into the virtual machine. So when we take a look here, for example, through PowerShell, through the agent, and here's just a few examples, we can actually inject into the VM a PowerShell script. We can inject agents like the Symantec anti-malware. We can also inject things like the Chef client agent directly into the virtual machine. Microsoft has made a number of agents, or excuse me, a number of extensions, and we've also partnered with a number of ISVs who are building extensions as well. And you can also use Bash for the Linux environment, so this is done either through the UI, and we also have additional extensions that can be deployed via Bash or via PowerShell directly inside of the virtual machine. And in just a minute, I'll go in and actually show you the extensions and show you through the UI how to do deployment. So here's some examples of extensions that we have available today. We have Docker, we have simple things, simple scripts and tools as well, such as reset password. So again, have a running virtual machine, you want to do a simple reset of the password, you go ahead and inject that script. And the nice thing again is either through the UI or through PowerShell, you can put in all your specific parameters. So as you'll see in the demo, when you install something like an anti-malware agent, it will actually ask you questions. It'll say, where's your anti-malware server? And you'll say, this is the location of my server, or this is my license key. It will take that user-defined data, and during the injection of the agent itself, or the extension itself, it will use that custom user-defined information. So again, all across the board here, Chef and Puppet, Trend Micro, Symantec, Visual Studio, script extensions, PowerShell, DCS, all kinds of things. And then this one is kind of near and dear to my heart. I kind of injected this in here. This is the Azure Marketplace. Azure Marketplace is something that we've been focusing on a bit. As application developers, you may be familiar, but what we're trying to do is grab great applications, both first party and from our partners, and have a central location both in Azure and through unauthenticated on the web, where you can browse, you can find virtual machines, you can deploy virtual machines directly into your Azure subscription. Back at TechEd a few months ago, we announced that we had over 50 partners that we've worked with to build great new images into the Azure Marketplace. Since then, we've added dozens and dozens and more, and we're really starting to engage to build a great ecosystem. As you're building your apps, as you're wanting to get them out there, if they're for general use and consumption, think about the Azure Marketplace. We have monetization options as well. Our partners who are building applications and putting them into the marketplace are using typically one of two methods. Either number one, hourly billing directly through Azure. So you actually go through during the publishing process and you identify what you want to bill for your application on top of the general Azure consumption. So you say for an A4 virtual machine, I want to bill X cents per hour. For a D4 virtual machine, I want to bill Y cents per hour. Additionally, we allow for what we refer to as BYOL, or bring your own license model. So if you already have customers who have licensing contracts or site licenses with you, and all they want to do is basically use their licensing key for their application inside of Azure, you can use that as well. So a lot of our partners and a lot of our app developers are building both bring your own license versions of their software, as well as leveraging the Azure bill as they go. With the pay-as-you-go, the customer basically gets one bill from Microsoft, which includes the Azure Compute, and the cost for the application from the ISV. And then what we do is we gather that money and then pay back the application developer or the ISV for that software. Okay, so let's actually look back in the system. Let's take a look at some of these. So if I go back in and I just create a new, am I up? I am. A new virtual machine. We're going to say new. We're going to say compute. We're going to go down to Azure Marketplace. So right here, integrated into the portal is the marketplace. You can also go again on azure.com. There's a link to the marketplace as well. So even if you don't want to be authenticated or log into Azure, you can see all the different workloads that are available. You can see it's broken up into many different things. Under virtual machines, I can click the more option, and then it's going to show you lots in theory of virtual machines. 5, 4, 3, 2, 1. Well, there's lots. Hey! Oh, it looked like it popped up, and then it went away. Uh-oh. Long running. Oh, there they are. Wonderful. Very, very good. So these are just in alphabetical order. You can see solutions all across the board from AlertLogic. Barracuda has solutions in here. We have solutions from Riverbed. We have CoreOS, which is platform images, anything that you can possibly want. So if we just keep it real simple, we're going to go ahead and select one of our virtual machines here. This is just Windows Server, nice and basic. Let's go 2012 R2 is fine. We'll go ahead and say create. And when it brings up our options, I'll give it a name, if it will let me. There it goes. We'll just call it Brian T1, username. You don't know how hard it is for me to actually type my password without verbally saying it as I type. So it was very good of me not to do that. And if we keep going on and we go into optional configuration, right here is where we can bring in extensions into this virtual machine. As I mentioned, you can do it at time of deployment, and you can also do it post-deployment as well. So if I add extension, Here's some of the ones that are in the marketplace right now. There's also a lot more that are outside of the marketplace that we'll be bringing in short order. But for example, we have Chef, we have McAfee. If I go in and just select the Microsoft anti-malware one, and if I click create, you can see it's going to ask me for some of the parameters. So again, this is the user parameters that right here in the UI are through PowerShell. We can basically set and say what the endpoint is, what it's connecting to, what the licensing type is, and during VM creation, we can go ahead and deploy that extension. Okay, so let's switch back one more time. And actually, with that, it's right back to Corey. There you go. So here is the clicker. And thank you very much.
All right, thanks, Brian. All right, so I'm going to close out with basically talking a little bit about what's new and new and open with IaaS. So we'll go through this and walk through what we've got. So just to give you a sense of just like how we view the overall compute continuum in the world here, we view it sort of in this ultimate control, rapid deployment sort of continuum, right? And so VMs all the way to the left, and this is sort of complete control, complete ability to configure every single detail you want. VM extensions is a little bit further along, right? It's gonna do some of the configuration for you. It's gonna automate some things for you. It makes it easier, but it's still sort of that underlying VM still underneath. Then you go further to the right, and we've got a service called Azure Batch and Service Fabric, which now you've seen or heard of, which takes a little bit more. It's still running on a VM. You still can sort of log on, and it feels like a VM, but it's gonna take care of some things for you. And in taking care of those things, you're giving it control, right? You're saying, you take care of my data replication, right? You take care of the fact that I have quorum on my application. And so that is sort of what you're handing off when you move to Service Fabric. And then all the way to the right, some of our higher level PaaS services that offer really fast of deployment, really easy to go, but then have a little bit less control, right? You're really giving a lot of control to the platform when you deploy app service, whether it be web, whether it be mobile, whether it be logic apps, right? All of these end up having a lot of the control sort of given for that rapid deployment. And so how do these things all come together? Well, I'm glad that I asked that because I'm going to answer. So the resource manager, the Azure Resource Manager, which is a JSON-based template, and this was the announcement that we actually just made. We made it this afternoon. It wasn't made this morning. We saved it for the afternoon wave of announcements. And this is support. Actually, it's been out for a while, to be clear, but we added support for virtual machines, networking, and storage to this. And so this is available today in public preview. And you can now piece together in a single template virtual machines, NICs, load balancers, all these aspects with PaaS services as well, SQL DB, web app, etc., and have a large application that puts all these pieces together. It also brings role-based access control onto the API. Today, role-based access control for VMs is only through the portal. It now can be controlled at the API level as well. You can do tagging on top of that. And then, of course, the whole template language is really some of the benefits, and I'm going to walk you through a few of those as an example. Okay, and so as part of this, I'm just going to pull up my blog. I'm just going to have you read it on the screen no, I'm not. Okay, that's not the real demo. All right, let me keep going. So some of the things for the way that you deploy this, the new resources that we've just exposed on the left, VMs, NICs, load balancers, security groups, public IPs, and VNets. These can now all be defined as JSON objects as part of a template language. They can all have dependencies between them. Right, so you can, in fact, you will require dependencies to do some things you want to do. Like you want to spin up a VM, well, you probably need the NIC to be created first. And so you'll say, create my NIC, then and only then can you create my VM. And so these sorts of dependencies can exist. Other really cool things about this, parameters. You can pass them all the way through. You can pass them all the way down to your extensions. And so even some of the most crude types of examples, you put a PowerShell extension that runs on the box, you pass a parameter down, you can do pretty much anything on that virtual machine. Same thing with our Bash extension. And we're seeing a lot of application developers who have typically come in and said, I'm going to create an image and I'm going to put it in the gallery, now saying, I'm just actually going to bring down my app on the fly and install it because now I don't have to patch the OS. And so this brings together a lot of that capability with the ability to run those scripts and that extension on the box with the template to be able to reuse it over and over again. Parallel deployment, as I mentioned. Deploying 10, 15, 20 virtual machines at once is not a problem. It's something that actually the system was built to do, and actually it can handle it very quickly because actually this API is running on top of a Service Fabric ring underneath it, which is sort of mind-blowing because Service Fabric, when you run it, will run on top of these VMs, but these VM API is actually running as a service on Service Fabric because of the throughput that's required for the API calls that are coming in. Other things that we have, the ability to do loops. So you actually can go in and put a single VM, and you can make it deploy 200 times. And we'll take the loop parameter, and we'll attach it onto the names of that resource as it's deploying. And then actually, as I mentioned, we have 3 FDs, so 3 fault domains that you can now deploy. And so one of the things I'll say, and I'll say this at the end, there's a deep dive tomorrow that's going to go through every single example and every single resource that I've mentioned here and explain how to use it and piece it together and so on. I'm just going to give you a few examples. And what we've actually released with this is we've actually launched a set of templates for you to go get started with or use to actually spin up virtual machines that you want to develop on. So great example, we have a Jenkins deployment, a couple MongoDBs solutions, Django, Zookeeper, SharePoint, Apache, PowerShell. All of these are available in our current, it's actually in a GitHub repository that I'll show you, and indexed on azure.com to deploy or learn from. Right? It's either way. Right? You want to use the Jenkins box, you can just deploy it and play with it. Or you can read how we did it and learn from it to build your own. You can even fork it straight there and build it right in GitHub. And so this kind of leads me into some sort of additional point here. A lot of the examples that I gave you, why a lot of the rest of Microsoft hates me is, in fact, the open source beard. We do talk about it a lot in the team. And it's actually amazing because before, when I did not have a beard, this is what I looked like. So I don't have that tie anymore. No, but it is one of the things that we do spend a lot of time on in the team, making sure the open source solutions work great. And it's something we're really passionate about. And so a great example of this is our Docker integration. You've heard a lot about this, so I'm actually not going to spend too much time on it. But we do have a deep Docker relationship. In fact, one of the templates I will show you is a Docker story. We have the ability to deploy a full swarm cluster right now using a template. That's one of the templates we actually have already, including we have the DCOS for Mesosphere as well. Some of the things that are coming, a deeper integration with Docker Hub into the Azure Gallery. You'll be able to deploy straight from Docker Hub, and a couple of container solutions that we've talked about pretty extensively already. Okay, and to walk through sort of examples of how these templates really work in action, Brian gave some of the details, but we're using templates like this to be able to deploy things that you already have in the portal today. And this kind of gives you an example of some of the power that you have. Being able to deploy DSC directly onto the box uses this template model. Being able to deploy Octopus uses it. Visual Studio Release Manager is already using it to be able to deploy and manage virtual machines that it's running inside of Azure. And of course, Chef, Puppet, and Salt are all using it to be able to configure the virtual machines when you deploy. And so as Brian said, the combination of the template parameters using extensions makes all this possible. The other thing that we announced today that I'm not going to spend too much time on but worth talking about, this API has opened up an entire additional wave of PaaS solutions that can run on Azure. And so it's not just Service Fabric, which is a great product, but we also announced today partnerships with Cloud Foundry, Apprenda, and Jelastic to be able to support all of these solutions on top of Azure. And so they're all running on top of this new API because of the agility and the flexibility to deploy. And it's very exciting to be able to have, again, this open story of PaaS solutions on Azure. Piecing these things together, you could have Cloud Foundry talking to SQLDB. I mean, you can imagine the options are really limitless. And of course, Service Fabric, the one that we've announced as well. And so when you sort of look at the overall story for open, operating systems, a wide variety, including FreeBSD, a wide set of Linux offers as well. Data, you know the drill. MongoDB, we have Oracle support as well as IBM DB and a MySQL offering, and of course SAP supported. From a development perspective, just across the board, and this is not necessarily just IaaS, but really Azure in general, the overall mobile story and the language story, and even the new support for the APIs that we have, we'll be releasing SDKs. Actually, we have one available for Node today. We'll be releasing one for Java very soon to be able to code directly to those, and of course the CLI is Node as well. And then, of course, tooling, and I'm going to show you Visual Studio in the 2 minutes I have left, and walk you through sort of what that looks like. So with that, I'm going to go to my demo here and just show you a few things, and then you'll be on your way. So let me start here with, nope, that's not it. Sorry, there it is. So go to Community and go to Templates, a new section. And here you'll see templates that are indexed directly from GitHub. So you add a template into our GitHub repository, it will show up on Azure.com. And to give you an example of this, it automatically searches for it. So let me go to my template. And so you'll see there's my ugly mug here at the top. It actually pulls the picture of the GitHub owner who created it. It will oh, I thought I put descriptions for my parameters. That's a shame. You can actually put in your parameters of what you're going to deploy here, and it will automatically update this. But then the best part about this is you hit Deploy to Azure, and it actually will automatically go into your Azure account, authenticate you. The template shows up in the portal. You can edit it here if you want to. If you don't, you hit Save, and then you go in and you put in your parameters and deploy. And it's just amazingly simple to take a very complex thing and deploy it within moments. And this is all indexed in GitHub, like I said. So the GitHub location, Azure Quick Start templates. And you can go in here and you can fork and learn everything you want to learn. And so here you can see, if I go to Django app, I can go in here, click on it, and there's the template ready to roll. Okay, and the very last thing here is, how many of you actually went to Mark's session this morning? Okay, a few. Well, let me just quickly show you this whole language now in Visual Studio is completely available to you go in and update and modify and play with. And they're going to spend a lot of time on this in the deep dive tomorrow. But just to kind of give you a few examples here, if I want to go in, here's the overall template you see here on the right. Let's see here. Zoom didn't work here. Oh, okay. So you can see here my parameters are all listed out, and I can go in and actually monitor them, and I can go find them in my template. So let's see, virtual machine name. Let's go to that, and it'll show you here's the template location for that parameter. It's a string, the description that comes in that metadata, and then I can go in and do plus, and I can add all sorts of things to the template language. I can add a NIC right here if I wanted to. I can add a PowerShell DSC extension, SQL Server, virtual network, and you go in and if you hit this and say, yep, let's do test. Okay, add, it goes in and it actually drops it right into my overall script, and I can go in and put the dependencies here and play with it. So the power of Visual Studio added on top of these extensions should really make this a lot of fun to go play with. And like I said, they're going to spend a ton of time on this tomorrow in the deep dive, and that's kind of the overall, the end point here. So go see the deep dive on Thursday, guys. Overall, I hope this was valuable to you guys. And go sign up. If you haven't signed up for MSDN, that's a great deal, great offer for you. And send me something on Twitter as well. And so thank you guys so much. We'll be here to answer some questions afterwards if you want.